Okay, today we are starting Unit 5, which is talking about quadratic functions. And this is our next step because it's kind of looking at the difference between linear functions and quadratic functions. And then we've looked at quadratic functions when we were talking about polynomials, especially trinomials in the standard form of ax squared plus bx plus c. And we've talked about our a, b's, and c's. Especially with factoring, we talked about those a, b, and c terms and coefficients. So what I want to start out with is looking at our examples and non-examples to help us figure out what is a quadratic function. What are the differences? What are some things that you see in the non-example versus the example? What are some observations you make, or what are some conclusions that you think you can say this is a quadratic function, this is not a quadratic function because? Okay, so a quadratic function, a function of degree 2, so that's one of the things we need to know. I'm going to do this in green today. Of 2 degrees, and it's in the standard form of a quadratic function. It doesn't have to be, but the standard form is, and because we're talking functions, we're going to use our function notation. If you remember, f of x, that's just a fancy way of saying y equals, or when we say a function of x, that means everywhere there's an x, we're putting x right now. We're just writing the function, but f of x is just a fancy way of saying y equals ax squared plus bx plus c. This is our standard form, that a, b, and c. We have seen this. We've been practicing with it, especially with factoring, so this should be something we're comfortable with. Where a, b, and c are real numbers and a does not equal to 0, so our leading coefficient cannot be 0. The graph of a quadratic function is called a parabola. That was P-A-R-A-B-O-L-A, parabola. So, what are parabolas? We're going to graph this, and what we're going to do, I think we're just going to do the first one for time's sake. But we're going to fill in this table based on our function. So what I'm going to do is everywhere that there's an x, this is saying f of negative 2. So everywhere there's an x, I'm going to put negative 2. Negative 2 squared is 4, positive 4, because the negative times the negative is a positive. Minus 2, so that's positive 2. Negative 1 squared minus 2 is negative 1. 0 squared, that's negative 2. 1 squared, we're back to negative 1. And 2. So with that square, it kind of, you've got to think about, it's going to end up being positive because a negative times a negative is a positive. So it doesn't matter if I have a negative or a positive, I'm going to get the same y value. So this is not a linear function. It would fail our linear function test. But we're going to go ahead and graph it. So we have negative 2, positive 2, negative 1, 0, negative 2. So it looks something, and I'm horrible at drawing, but it looks something like, I apologize for the bell, that. And we can see in our standard form that we have an a of 1, we don't have a middle term, so that's 0, and our c term is negative 2. Remember that c is going to be your constant, so that's why we skipped b, and that's not, there's not a x to a degree of 1 there. I am going to go ahead and skip this one for now, but if you would like, you could go ahead and practice filling that in, and you can pick the points that you want to use for your x value. And then that would determine your y value. But I want to go ahead and talk about the different parts or the different pieces of a quadratic parabola. So the first thing is the vertex. The vertex is the maximum or minimum, I'm just going to write max or min, point of the parabola. So if we were looking at this point, this would be our max right here. The maximum is the y value of the vertex maximum or minimum. So if they're asking you what is the max of this parabola, it would just be the y value because it's going up and down. The zeros are the points where the parabola crosses the x-axis. We've talked about this before, about the zero of the function, also called the x-intercept, roots, or solutions. So that's the zeros. And then y-intercept, I'm hoping we're comfortable with this one. That's the coordinate where the parabola crosses the y-axis. Could be the minimum and maximum, does not have to be the minimum and maximum. But if we're looking at the different pieces on the shape, so this is our y-intercept. This is a 0. This is also a 0. And this is the vertex. And the minimum for this one. Because it's at the bottom, that's why it's the minimum. So if it was up here and it was shaped like that, then it would be the maximum there. But that is the different parts of it. Let's go ahead and look at an example. Once again, I think I'm only going to do one of them since I'm short on time here. But if you want to go over, I will be posting the practice, so you can go ahead and practice a couple more problems if you would like. Okay, so we're going to look for the different parts of this parabola. What is the vertex? So the vertex is the highest or lowest point. That is at 3 and -4. So our max or min, which it would be a minimum of -4, because that's our y value. Zeros, where does it cross the x-axis? 1 and 5. And our y-intercept, where does it cross the y? Oh, no, that's not on the y yet. This one is right there. That would be 0, 5. I'll go ahead and talk about this one just real quick. This is our vertex. So it's at 0, 4. No, 0, 6. I read that wrong. That would be a maximum of 6. Zeros at -4 and +4. And our y-intercept is at 0, 6. It just so happens to be our maximum or our vertex point. So it can be both. It can be both, or it can be all of the above. So there's one more part that I want to talk about as the attribute of a quadratic, and that is the line of symmetry for a parabola. And the line of symmetry, which have an axis, it's called an axis of symmetry here. It's not a line of symmetry, it is axis of symmetry, but it's pretty much the same thing as a line of symmetry. It's the vertical line that passes through the vertex. So that's the important part. It's vertical and passes through the vertex of the parabola. Each point on the parabola will have a point with the same y value and the same distance from the axis of symmetry. Think of these points as mirror images. Mirror images. So this would be our axis of symmetry. And this would be our vertex. So that is kind of what we're looking at. So on this one, our vertex, -2, -7, and our equation for our axis of symmetry, this is our axis of, wow, that was not pretty. This is our axis of symmetry. And that line, remember it's not y equals because it's vertical, so it's x equals -2. So that is our axis of symmetry, our line for the axis of symmetry. But sometimes there's a way that we can calculate it. Maybe we don't want to look at the graph, we don't need the graph just yet, and it takes a lot of time to graphing. You could actually calculate the axis of symmetry when a function is in standard form. Remember, that's ax squared plus bx plus c. We can use the formula, it's at the bottom, to find the axis of symmetry equation as well as the x value of the vertex. So the equation is x equals negative b over 2a. So this is using the letters from standard form. So negative b over 2a is the x coordinate of the vertex. So there's ways that you can calculate it. So let's practice. So I am on number 4. Gx, 2x squared minus 20x plus 51. So if we take the negative of b, which is 20, over 2 times a, which is 2, would be negative 20 over, I'm sorry, that's a negative 20, over 4. A negative times a negative cancels out, so that's a positive. 20 divided by 4 is a positive 5. So the axis of symmetry is x equals 5. So the vertex is where our x equals 5. And you might be wondering, how do you figure out the y value? Well, we just substitute. Instead of g of x, it's going to be g of 5. 2 times 5 squared minus 20 times 5 plus 51. And you can do all of the calculations, but the answer turns out to be 1. So let's do it again one more time. We have negative b over 2a, negative 8 over 2 times a negative 1. So that's negative 8 over negative 2. These cancel out, but this one still stays there. So I know my answer is going to be negative 8 divided by 2 is 4. So my axis of symmetry is x equals negative 4. Substitute my x value in for my equation. Y equals negative 4 squared. It's negative 4 squared. So you square, then do the negative. Minus 8 times 4 minus 8. So 4 squared would be negative 16. That's not right. Negative 4. Oh, these are negative 4. 8 times 4 is 32 minus 8. That would leave me with, if this is negative 4, then that's a positive 8. So that is how we're doing attributes of quadratics.